Welcome to Study Loop.
Okay, so first of all, we have given calcium chloride here, CaCl2. Now, see here the basic concept involved for all of the given solute and solvent. The basic concept is like dissolves like rule, that is, polar solute dissolves very well in the polar solvent, and the non-polar solute dissolved in very well in the non-polar solvent. Okay, so now CaCl2, so that is a ionic solute, and being ionic, so this is ionic polar solute. Okay, so this means that CaCl2 will dissolve very well according to like dissolves like rule in a polar solvent. Okay, now the options we have given here: CH3OH. So let me represent that. So I have a oxygen atom with a lone pair of electron, and now this oxygen is electronegative in nature. So being electronegative, it has partial negative charge over itself, and now this hydrogen is attached to a electronegative atom, so all its electron density being withdrawn, and this has partial positive charge. Okay, so there is polarity, right? And there is the dipole moment. Okay, so whenever there is a dipole moment, there is a certain amount of dipole moment, then we say that we have a polar molecule. Okay, because here we have certain amount of dipole moment. Then we have given here CCl4. Okay, so or CCl4, so the structure will be, the carbon is the central atom which is attached to 4 chlorine atom in a tetrahedral manner. So now here each carbon chlorine bond, that is polar in nature, because chlorine is more electronegative than carbon. Okay, so this will be the direction of dipole moment, but as we sum up all these dipole moment, okay, so being equal and opposite, these dipole moment cancelled out each other, these dipole moment nullify each other. Okay, because this is a symmetrical molecule, this CCl4. Okay, so here we can write that among this CH3OH and this CCl4, this has dipole moment, this do not have dipole moment. So this is a polar molecule, this is non-polar. Okay, so CH3OH, so that is a polar and this is non-polar. Hence CaCl2, or I should write better solvent for CaCl2 is CH3OH. Okay, okay, so this is methanol here. Now moving on to next, we have given, next is we have given here urea. So that is the structure for urea. Okay, so that is polar. The reason being, we have a bond between carbon and oxygen. So oxygen is more electronegative than carbon, and that's why we have polarity here. Okay, now since this is polar, this means that it should be dissolved very well in a polar solvent. Okay, so now we have given here DMSO, that is dimethyl sulfoline oxide. So the structure we have given here, that is CH3-S double bond O CH3. Now that is also polar sort of, because we have sulfur and oxygen, both are from same group, but here oxygen is more electronegative than sulfur. Okay, so that's why this will be the direction of dipole moment. So that is polar, and H2O. So let me draw the structure for H2O, that is water again. So we have a structure like this. Okay, so now here we have oxygen which has partial negative charge over itself. Okay, and now this has hydrogen which has partial positive charge. Okay, so oxygen is more electronegative in nature, that has tendency to withdraw the bond pair of electron towards hydrogen from hydrogen. Okay, so that's why we have here partial negative charge over oxygen. Okay, because the negative charge gets accumulated over oxygen, and hydrogen, since it is attached to the oxygen atom which is electronegative, so all their electron density is being withdrawn and they have partial positive charge. Okay, so that's why this will be the direction of dipole moment from hydrogen to oxygen. So yes, this is also the polar, right? Okay, so is also polar. But now when we dissolve this urea into this water, so there is also possibility of hydrogen bonding. We have to choose for the better solvent. We have to compare between them. Okay, both are polar, but when we compare, so this water is capable of hydrogen bonding also. Okay, and forms hydrogen bond to due to interaction of oxygen hydrogen. Okay, so with this electronegative oxygen atom we can have interaction of this hydrogen atom. Okay, so there is a direct interaction of hydrogen to the electronegative atom, and that's why hydrogen bonding is possible here. Okay, so hence H2O is better solvent. Okay, so now that is the answer, H2O. Moving on to next, we have third part. This is CH3 CH2 whole 4 CH3. So this is what? This is hexane actually, okay, containing total of 6 carbon atom, and all carbon atoms are being connected by a single bond. So this is a alkane chain with 6 carbon atom, that is hexane. Now whenever we have a alkane, okay, when we have alkane hydrocarbon, so that is non-polar, okay, that has no polarity. So this means it should be better soluble in a non-polar solvent. Now, so CCl4, I told you before in the first part that CCl4 is non-polar because that was a symmetrical molecule, and the being equal and opposite, all the dipole moment cancels out each other, right? So CCl4 is non-polar, and H2O, as I told you earlier, that is polar. Okay, so that's why, hence better solvent is CCl4. Okay, So CCl4 is the better solvent.